Hello everybody, it's me again, talking about FPGAs and MicroTCA workshops. I'm going to be talking about FWK. You probably heard this a lot. We had a very nice tutorial session also yesterday, so some of the slides are going to be reused. What is FWK for those who don't know? It's essentially an open source FPGA framework. It's written in the language of Tickle. It's around 11,000 lines of code, and its job is to essentially automate the creation and build processes of EDA tools. EDA tools such as Vivado, DESY, PlanAhead, GHDL, and so on and so forth. And what it does is it helps FPGA developers to come up with prototypes in a rapid fashion. And it achieves this with the concept of what we call a module. So it forces developers to abstract the code from another such that we increase the reusability of an IP. And this is particularly the killer feature of FWK. FWK itself is not necessarily useful, actually. What it makes it amazing is these modules that we give to the community, and I will talk about that. But so let's talk about the supported tools. These are all the tools we support so far, and each month or so there's a new one gets added. Of course, you have the AMD tools. We have ModelSim, PlanAhead, GHDL is also another cool tool, open source VHDL simulator. We support Yocto as well, so it's not just bit streams, but we can also create full-blown embedded Linux applications as well. And even some linters like Teros HDL or verification methodologies like VUnit or CocoaTB is also that we can also support. So why am I talking about FWK in a MicroTCA workshop? Because they're very related. What they are trying to achieve is, in philosophical sense, it's the same. So in a MicroTCA, what we actually do is we abstract hardware from another, right? We group hardware by functionality. Like, let's say we take the management-related electronics and we say this is an MCH module. And then you could have AMCs and RTMs, and the whole point is that we have these commercial off-the-shelf solutions where customers can buy these modules, pre-made blocks, and then you can quickly assemble these things in your crate and you come up with a solution quite rapidly. I think this is why this is why I think scientists really like this standard, because it's not necessarily tied to a certain company's solution. It's just standardizes interfaces, and then it just becomes these Lego blocks that people can just exchange from another. FWK does this basically the same, but in the world of FPGAs. So what we want to achieve is essentially create a platform where people can exchange IPs in FPGA world easy. Hence, we increased the collaboration in the scientific community. And the key to that was the open source. And around 5 years ago, we made a strategical decision to really change our firmware structure to be more open source and open our existing IP to outside. And we've seen significant progress being made in the community with using these modules. So in MicroTCA, you have MCH, AMC, RTM. In the FWK world, you have stuff like BSPs, application libraries, or maybe Yocto layers, like bit-baked layers, right? So where is FWK used, maybe is also another important thing. It's spreading. Obviously, it started at DESY, and we heavily rely FWK for most of our machines. In fact, for example, European XFEL is one of our biggest success story with FWK. Even before we rolled out FWK to the public, we were testing FWK builds in XFEL, and it worked. And then more and more people started to join the cause as soon as we made it open source. And now we started to see FWK in the wild, where some of our colleagues goes to overseas for some conferences, and then we started to see people talk about FWK even without our knowledge. That's actually quite exciting, because that shows that it's being now slowly discovered by the community and the attraction is growing. And that's my job. I mean, my job is just to yell and so people pay attention to us. But the real goal here is essentially try to create a platform for the scientific community, and I feel like MicroTCA and FWK kind of goes hand to hand, because at the end, again, the key word is abstraction. And abstraction allows you to then bury the complexity under the hood. such that you could then build stuff on top of it. Because not everybody has time to understand how PCI Express works or how DDR should be worked. I mean, you just want a data. Like, you just want RF signals visible. A lot of the times people don't care how the implementation detail happens, right? So that's exactly what we do. And it's shown that community likes this. So hopefully next year, if I talk again, hopefully this will grow. That's my hope. So how does FWK work? It works like a Lego piece, actually. So you can imagine these modules like a Lego piece. It's the same idea. It's standardized that you could just go and buy Lego pieces and attach them together and create your own Lego solution, right? We want to make the same in FWK. So you start with a module, which is, you could consider it as a Git repository of an IP. It's just a container, right? And what you do in FWK is you just create these Lego bricks, and all you have to do is to write one Tcl script to describe FWK what this Lego piece needs. For example, this module can need maybe a bunch of source files like VHDL code, VHDL source code, system Verilog. It could have software like maybe a bunch of C, C++ code, Python scripts. It could have a documentation inside as well, which is always a good idea to attach the documentation along with the source code. Yocto recipes, you name it. So there's a lot of things that this Lego piece can handle. But the key point here is that it's standardized. So if you take a bunch of different modules, they should be able to plug in each other. So we have lots of types of modules in FWK. It changes in complexity and size. There are some small, stupid modules that does nothing that big, but sometimes you have very big modules. We call them, for example, board support packages. These modules actually have a lot of IPs inside, but what it does, it's, for example, in the MicroTCA world, let's say you bought an AMC, we want to be able to give you a Lego piece that actually handles all of these PCI Express and memory interfaces that you have, clocking, all of that stuff that is not related to the application. We want to give this to you as an open source package. And in fact, last year I said this, and I think I can safely say this again. Every time our group makes an AMC board, you should expect from us to give you also open source example design that goes along with it. And we think that these example designs are the ones that community cares the most, because that's where you start, and you start to add your application on top. And of course, modules can use modules, so you could plug these modules together, and that becomes its own IP, right? So that's also critical functionality of the FWK. And then once you put everything together, you have your nice little prototype. It might not be perfect, but that's okay, because you already have something. Something is moving, you start to read some data, and that's where we want to take you. So we have a lot of modules, as I said. I counted, actually, we have about 108 modules inside internally, out of which 25 is already open sourced. But I can promise you that our team and our management is very clear on this. We want to increase this number more and more. Of course, if we write papers about it, you might not see it, but we have a lot of IPs that we already published everything about it. There's not much stuff to discuss. So why not just open it so that people can use this and create maybe more better things with it? Last year, when I talked about FWK, there was a gentleman in the audience that said, why don't you increase support for the evaluation boards? And that's also exactly what we did. I mean, of course, MicroTCA, we use it heavily, right? I mean, FWK has a lot of MicroTCA related projects, but it doesn't have to be, because not everybody needs MicroTCA immediately. There's always this intermediate stage where you could get some sort of an evaluation board and maybe do some prototyping. And we saw that, and we started bringing supports for these AMD evaluation boards. For examx our FSoC 4x2 is the one good example. We have now support for this. SCKCEN is also helping us to kind of fine-tune this BSP, and it's going great. ZU208 is another example. And as I said, we started to see FWK in the wild. In fact, just before this conference, I've been informed by Polytechnic University of Madrid that they just said, hey, we took FWK and we just created this BSP for Kria board, this $300 cheap UltraScale Plus FPGA, and they just created a whole example design out of nothing. And they even agreed that we might host this in our GitLab. So this is the kind of thing that I want to see, that people just create these board support packages for people to use, so it creates this marketplace of IP. All right, so unfortunately, I don't have so much time to describe everything. And as I said, we did approach 1.0. This is a bit political, of course. I mean, when do you say software is done? Of course, it's never done. It's gonna be 2.0, 3.0, 4.0. Who knows? It's gonna outlive me. I mean, a lot of the team might change, but FWK will stay. And but we still wanted to say 1.0 because we now believe that it's reached a point of critical mass that now we had to do a bit refactoring. And we also decided to completely overhaul the documentation. We've written from scratch with the help of AI, actually. And I mean, it's not AI slop. We did edit it, and we made sure that it's not wrong. But it's now in a better shape. And we also wrote a lot of tutorials for you guys, such that this new 1.0 Tickle interface is clear to you. So you could then hopefully change your modules to be compatible with this new version. This 1.0 is also signifies that over this 5 years of FWK development, we had about 20 contributors, and if not more. I cannot count it anymore because every month new person comes in and creates a merge request, which is great. And external facilities and companies started to join, and companies as well is also pretty exciting. And as an outlook, as I said, MSK Group is committed to maintain FWK, which is should be a reassurance to the community that this thing will be supported. It's not just someone's personal project. It is heavily needed in DESY, and it will continue to stay. And we already started planning 2.0, but this time we want to do it a bit more as a community project because we don't have now the luxury to decide everything by ourselves, because now we have to consider everyone's needs, and that's a bit challenge, but hopefully it will work out. And please check out our documentation and tutorials. The links are here, and I would like to thank you for your attention.